Okay. So, somewhat recently, I don't remember when, but I was working on some DP stuff, so I want to continue that. Today's POTD was quite easy, so I'm happy to keep going. Let's see what's another problem I can try. Again, I'll probably stick with medium problems for now. I read part two of this. I don't think that makes sense. Palindrome partitioning. House rubber looks interesting. Let's try that. I'm a professional robber. Oh god. Why am I the okay? Why did I have to be the professional robber? All right, you are a professional robber planning to rob houses along a street. Each house has a certain amount of money. Have I done this before? No. Okay. I knew that, but I don't know. This feels familiar, but maybe yeah. I guess anyway. Yeah, planning rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing every single one of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Interesting. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob with tonight without alerting the police. Okay. So the advantage I have is the fact that I know it's a DP problem. And I can kind of sense where the DP might come in a little bit. So nums 1, 2, 3, 1. So you have these are the four houses with their monies, and they're saying the biggest you can make is 4. I can see that you could steal from 1 and then steal from 3, and that'd be pretty good. Or and if you tried something else, if you tried stealing from like 2, you would only be able to steal from 1 because you can't steal from 3 because it's adjacent. And if you stole from 3 first, then you wouldn't be able to steal from anyone else afterwards because you can't steal from 1, and there's no more houses after that. Similarly, um, you could do 2, 9, and 1, giving you like um, 12. Sorry. If you tried 7, you'd only be able to get to 10 with the 3, and that's it. If you try the 9, you get to 1, and that'd be it. Is there any. Okay, so see, from these particular examples, I'm like very specifically either taking like the odd position or the even position houses. Like these are the even position houses, 0 and 3, 0 and index 0 and index 2. And then you try. But I assume, especially since it's DP and the fact that the constraints are quite small. But there's a part 2 to this, isn't there? So I'm assuming that. Oh no, the constraints are the same. The constraints get a bit bigger, maybe. Okay, that's not. Okay, it's fine. It's fine. Um, whoa. Okay. So my thinking is if we really try to take a particular example. So let me get rid of this. So this is 198 house robber. So yeah, if I take one of the examples given, and it's like 1, 2, 3, 1. So the houses or whatever it's called, nums, has cash 1, 2, 3, 1. Bearing in mind that I know it's a DP problem, my thinking is something like, let's say I define my like query to take in one parameter, and what this question is telling me is, given the first no, I have the idea, given the last I houses, what is the largest amount of cash that I can get as a burglar or whatever, robber? So what do I mean by that? Well, Q of 0 means given none of the houses, what can I do? So 0. Q of 1 means given just the last house, what can I get? Well, in this case, it'd be 1. Q of 2 means given the last 2 houses, what is the amount I can get? Well, it'd be either 3 or 1. It'd be the maximum between 3 or 1, which is 3. Q of 3 would be saying, given the last three houses, 1, 3, given these three guys, what's the maximum I can get? And this is where we sort of try to decide our recurrence relation. Either I take the 2 from here, and I add the maximum that I get from the very last house, which would be 1. Sorry, which would be 2 plus 1, which would give me 3. Or I can ignore the 2, go straight for the 3, which I guess would be saying ignore the 2, and in that sense, just go for Q of 2 equals 3. Yes. So I would take the maximum. I take the maximum between these two, and I would get 3 because they're the same value actually. Now Q of 4 is saying given the last 4 houses, that is all the houses, given all the houses, what's the best I can do? And this is how I would get my answer. And trying to apply the same recurrence relation, it would be either I choose to take the 1, in which case I can't take the 2, but I can take I can figure out what the maximum is for the rest of the houses, which is Q2. Sorry. Or I can not take the 1 and instead try Q3 and take the maximum between these two. So Q2 is 3, so that gets me 4, and Q3 is 3. So the maximum between these two would be 4. And then I would return Q4 because that's all the houses. I think that's it. I do think I've done a similar problem, which is why that jumps to mind, but I have to be a little bit careful, make sure I don't do anything silly. dp equals, so I want 0, 1, 2, 3, 4, so I want 5 spots. So if num houses is equal to the length of nums, then dp, I just want the space, right? So num houses plus 1, so that gets me my array. And then for I in range num houses plus 1. So we'll do going through each of these cases, Q0, Q1. Maybe I can say from index 1, because dp of 0 is always 0. dp of dp of 1 is equal to just equal to the last house value. So I think I can actually start at index 2, sorry, from query 2 up to query 4. So then that's exclusive. Yes. And if there's only one house, and this for loop just won't run, I think. My options, option 1 is I take this house. So I have to figure out the query. So nums at, is it minus I? Would that work? Minus 2, yeah. Plus dp at I minus 2. Option 2 is equal to is equal to dp at I minus 1. So either I take this guy and I take the maximum across the rest, or I just take this guy. Or I take the maximum from here. So either in other words, this is either it's the maximum between nums at minus 2 plus dp at 0, or it's just the dp of 1. Given the last house, what's the best I can do? And then so dp at I is the maximum between option 1 and option 2. Okay. And then just return dp Return DP of num houses, given all the houses available to us, which is that's a valid index. Yeah, is that it? What else could I do? Let's say you got like 500 and then you have like what's an example where you wouldn't just like take the alternating houses? You got a 500 at the start and you got like a 499 over here. um 500, 499. Wait, I want an example where you wouldn't take. I want an example where you wouldn't just take an alternating approach. Like if you've got like a really big number. Something like this. Yeah, I think this is good. Yeah, this is the one. So this obviously should be 900. Take this guy, they're not adjacent. But if you take the alternating approach, you'll either get 401 or 501, both of which are bad, or not as good. So 400, 1, 500. So this should give me 900. Oh, my fault. 200, 200. It's more of a conceptual 500 than a real 500. Yippee! Okay, I back it. I think mathematically it makes sense. Nice. Alright, and then I'm just curious, is this any different? Oh, they're in a circle. How does that change it? If I take the first, if I choose to rob the first guy, I can't rob the last guy. Interesting. So you either take the 3, or you take the 2, or you take the 2. You cannot take you cannot take both 2s. Because that would be robbing adjacent houses, even though they don't look adjacent. They are adjacent. Do I want to try this one straight away? If it's similar enough, I might be able to do it. Alright, let me get rid of all this because I imagine the recurrence is slightly different. 1, 2, 3, 1. I don't want to touch the 1 now. Like when I'm deciding this guy, I'm not allowed to take this guy. This circular thing doesn't affect any of these previous cases, like the logic is the same, but then when I get to this guy, it becomes a question of whether maybe I just have to keep track of whether, maybe I need to have 2 dimensions. One where you do use the 1, and one where you don't use the 1, like don't use the last value. And then like I don't know if that made any sense, but basically my new relation or my new query would be given the last I houses, Jesus, my handwriting is awful, houses, what is the max cash you can get if you use the last house and if you do not use the last house. So there's kind of like two outputs that each query should give, is my thinking. And the idea is, so yeah, Q of 0, still 0, because you're not given any houses, how are you going to rob anyone? Q of 1, there's going to be two outputs, or 0, 0, I guess, should be the structure. Two outputs. If you do use the last house, then the output should, then you get 1, because you're going to use the last house. If you're not going to use the last house, why does this look so weird? Why did I put like 4 brackets? If you do choose the last, if you use the last house, then yeah. Otherwise, no. Q of 2, given the last 2 houses, either you choose to, okay, answering part A, where you are allowed to use the last house, well, you're not going to be allowed to use, well, we'll see. If you choose to use the last, what the heck? So answering part A, if you're going, you can either choose yourself, so nums at -2, plus Q of 0, Q of 0, where you are allowed to use the last house, or you don't use yourself and you use Q of 1, where you are allowed to use the right house. And I think you max between these two. And for part B, you do nums of -2, where you're not using the last house, plus Q of 0b. That is to say, taking this answer but using the B answer, where I'm not using the last house. Or you can take Q of 1b, where you choose not to use yourself, you choose to use this guy, but you're not using the last house. And so you get, and then you take the maximum between these two. So computing it, part A, you either get you get 3 or 1, which is so maximum is 3, and then nums -2 is 3 plus, well, 0, so 3 or 0. This is 0, so maximum between 3 or 0 is also 3. In this case, if you have the last 2 houses, the maximum you can get is 3 either way. If you do use the last house or you don't use the last house, well, to be fair, you wouldn't be using the last house anyway. Okay, now for Q3, where you have the last 3 houses under your belt, same kind of deal. Answering part A, I can either take the last, I can either choose to use this house, so nums at -3, and then I can't use this house, so I have to use this, I have to start from here, so Q of 1, 3 minus 2, using the part A answer, or I can choose not to use, -3, so I'm using Q2 at A, and I take the maximum between these two. And similar idea, either I choose to use this house, and I choose to use, I can't use the next house over, so I use this, but I'm doing part B answer, or I choose Q2 at B, max. So Q3, I'm saying, so for part A, it's either 2 plus 1 gives me 3, or just straight up Q2 at A, just 3, so that's just 3, or I can do nums -3, so 2, plus 1b, which is 0, so I'm left with 2, and the maximum of 2b is 3, so that's also 3. This is not as interesting an example. Yeah, that makes sense. So what they're saying is either I go 2 then 1, if that's the using the last, that's me using the last house, and not using the last house, I can just do that one. And finally, Q of 4, using the last 4 houses, that is using all the houses, part A is nums at -4 plus q of, I can't use q3, so I have to use q2 using part A, or I can do q3 using part A, and I take the maximum between those two, and then for part B, I can take nums of -4 plus q of 2, but using part B, that's without using any houses, and then nums, and then, or I cannot use my -4, so I use -3. Oh my goodness. I keep doing that, I keep clicking on the pen. Ignore that. And I hit the maximum between those two. So then it's equal to, -4 is 1 plus 2a. So 1 plus 2 of a is 3, so you get 4 for that top thing. Or I can get 3 of a, which is 3. So that's, my maximum is 4 there. And then nums at -4 is, we said 1, plus 2b is also 3. And this is, and then we would specifically return this answer, I think. Would we? Well, this is like kind of illegal because we can't go to the very last house if, we can't go to the very last house if we're using the very first house, you know? I'm a bit nervous though because like this makes it seem, this answer saying I never use the last house, which could also be wrong because what if you have 1, 1, 1 and like 100? That just means you take these two houses. Just don't take the first one. Like if your houses are like 20, 1, 1, 1, 400 or something, then okay, just take the 400 and take the 1. Because of course if you take the 20, then you can't take the 400. So that would be your options. So my DP idea would be at the I think basically I just take I look at this value and this tells me if I'm going to use my thinking is I just go through all the DP values and just find the biggest number. And I ignore this number because this is a bit strange because this is saying using the first, potentially using the first house and also the last house, which is not legal. So I think I ignore that one. I just focus on that one. I don't know if that makes sense. I feel like this generally works, like this idea of passing down the information of like whether you choose to use the last index or not. But I don't know if it's actually correct. Let me try it again with the proper example, this example. It's a bit shorter as well, so hopefully that helps. So 2, 3, 2. So q of 0 is always 0, 0. Q of 1 is equal to, either I choose to use the last house or I don't choose to use the last house. If I choose to use the last house, it's 2, otherwise it's 0. So those are like my two base cases. And then Q of 2 is when we use our recurrence. So Q of 2 means we're starting here. Either you choose to use this guy and you don't choose to use this guy, in which case you get 3. And then, so either you choose to this and you're allowed to use this, or you choose to, well, in both cases, you're not actually going to be using the last house, so it'll be the same answer twice. And then Q of 3 means, given the first house, given the first three the last 3 houses, which is all the houses, either I choose to use this one. What is the best I can do? Well, if I'm allowed to use the last house, then it's this plus Q of 1 at part A. So it's 1 plus, it's 2, sorry, it's 2 plus 2, which gives you 4. And then if I'm not allowed to use the last house, then it's 2 plus, it's either 3 or 2, so you get 3. Does this answer tell me the right answer always? I think it might, you know. I think this answer tells me exactly what I need. Because like, either I'm like all of Q3 is saying is given that I've gotten access to all the houses, do I use this house or do I not use this house? Nah, but what if I do try this example? Let's say 21 and 400. In this case I shouldn't use this house. In this case I should. So what happens then? Q of 0 is equal to 0, 0. Q of 1, given the last house, is 400 and 0. Q of 2 would be, if I choose to use well, it'll be 1, 1, because I'm not allowed, like if I'm going to be using this guy. Oh no, sorry, it'd be 401, sorry. Because if I am allowed to use the last house, I would use it. If I'm not allowed to use it, I would use this one. And then Q of 3 is, if I'm allowed to use the last house, then I would say 400 plus 20 gives you 420. Maybe I just need like a special case. If my I is equal to the number of houses, then the recurrence changes a little bit. Then the part A answer is the same thing as the Q I minus 1 at part A, where I don't use this guy, but I'm allowed to use the 400 if I wish. So in this particular case, it would be Q of I minus 1 at part A is also 400. And then if I'm not allowed to use it, then I get 20 plus nothing, or I would get 1. So I could put 20. This is a little bit scary, but I think it kind of works. Alright, let's see what happens. So dp is equal to num houses is equal to length of nums. dp is equal to, doing tuples now, times num houses plus 1, and then so dp0 will always is already set up for us. dp of 1 is equal to nums at minus 1 and then 0 is the idea, and then for I in range 2 up to num houses plus 1, same for loop. So yeah, if I is equal to num houses, then deal with that. Otherwise, I think we can do the regular thing. So allowed last house is equal to, so it's the part A answer, is either nums at minus I plus dp at I minus 2, given the part A answer, or dp at I minus 1, given the part A answer, and it's the maximum between these two. And then not allowed last house is equal to the maximum between, exact same thing except part B. I might have constants just to, so allowed equals 0, not allowed equals 1, just to, I don't know if this improves readability, but I like getting rid of magic numbers where it can help. Why am I so zoomed in? Okay, so not allowed, the last house is that, and then dp at I is equal to that tuple. Allowed the last house, not allowed the last house. Else, do all this. And then from this, I'm basically saying, if I'm allowed the last house, then it's purely the same as dp I minus 1 allowed the last house. And if I'm not allowed the last house, then it's the same thing, I think. Either I take this house and I look for all the other houses that aren't adjacent, and I take that maximum, or I ignore this house and I use this one where I'm not allowed the last house. And then dp at I is equal to this tuple. And I think I'm allowed to return the maximum. If I just give the tuple, does that work? dp at I? Oh, it does. It works for the test cases. Okay. The acceptance rate is less than 50%, so if I fail once, I think that that's acceptable. Oh. Oh my god. Oh my god. Wait, how did it pass? Well, that's embarrassing. This should say num houses. How did that work? Okay. Yippee! Alright, yeah, so that's the idea. It's kind of like a, I guess arguably it's a 2D array. It doesn't really, like a 2D DP problem. It's not really 2D though. 2D normally you think of like 2 parameters. It's not really 2 parameters. I guess allowed, not allowed is a parameter, but like, it's not really a parameter. What do people do? I'm sure you do it simpler. Normal Rob. Oh. -2 equals num start -1. So like, wait, what? Is this like given the last 2 houses, given the last house? Maximum between nums at start, nums start plus 1, current equals -1. For I in range start plus 2, n plus 1. What is end? Oh, yeah, okay. So from 0 up to n minus 2, or 1 up to n minus 1. I guess that makes sense, kind of, in the sense that, like, if you're given, let's say this particular example, 2, 3, 2, what you're really trying to do is you're trying to, since you're not allowed to do these two, what the robber really has access to is basically either this guy, these houses, or these houses. So you just try both. That's quite clever. Very nice. I don't really know what's happening here. I'd assume it's similar to what I did, but he doesn't even have a DP array. To be fair, my recurrence only ever relies on Q minus. You only ever rely. If I go back to the other problem, I only ever really rely on the last 2 subproblems, right? dp I minus 2, dp I minus 1. So instead of having a whole array, you could just store the last 2 answers. And I'm assuming that's similar for that's similar for this. Okay, fair enough. I like the DP array just because like the idea of like just querying, like doing this query thing, the DP array makes sense to me because like I can index and it's like the same thing. Like syntactically it looks similar, like, but no, fair enough if that's obviously the space wise that's not as good. How do I just want to look at the solution again? So yes, your -2 is like your q minus is your qi minus 2, and then at -1 I assume is your qi minus 1. So qi minus 2, qi minus 1. So the current is the maximum between num_i plus plus qi minus 2 or just qi minus 1. Yeah, that's really clever. You just give access to only either from the start up to n minus 1. Sorry, not n minus 1, n minus 2. Like you don't give access to this guy, or you don't give access to the start and you give access to the rest. And you do the same problem. Very cool. Fair enough, fair enough. Wait, why did I click that? I didn't mean to do that. Anyway. Alright, that's good though. We'll take it.